Hello. In this video we're going to use derivatives and limits to help us graph the equation we have above, f of x equals x cubed minus 6x squared minus 15x plus 50. So first we're going to start by finding any maximums and minimums that we have. So to find max and mins, we find our critical points, and our critical points can be found by doing our first derivative. So our first derivative, we get 3x squared minus 12x minus 15. And our critical points will occur where that is equal to 0. And so I'm going to solve this thing for x, and it's a quadratic. I'll start by dividing everything by 3 and factoring. So this factors into x minus 5 times x plus 1. And so our critical points will occur at 5 and negative 1. Well, since our polynomial is continuous everywhere, those must have a maximum and minimum value. So we can figure out what those are by figuring out what is f of 5 equal to and what's f of negative 1 equal to. F of 5 is 5 cubed minus 6 times 5 squared minus 15 times 5 plus 50. 5 cubed is 125. 5 squared is 25 times 6 is minus 150. 15 times 5 is a minus 75. And then that's a 50, so plus 50. 25 minus 150 is a negative 25. Minus 75 more is a negative 100. Plus 50 gets us a minus 50. So f of 5 is negative 50. Strong guess that that's an absolute minimum, or a relative minimum, excuse me. How about negative 1? Negative 1 cubed minus 6 times negative 1 squared minus 15 times negative 1 plus 50. Negative 1 cubed is negative 1. Negative 1 squared is 1 minus 6 more. Negative 15 and negative 1 makes plus 15 plus 50. So negative 1 and negative 6 is negative 7. Plus 15 is 8. Add 50, we get 58. And so we have on our graph, we know we have a minimum value, a relative minimum at 1, 2, 3, 4, 5. And then we'll say that this down here is our negative 50. So 5 negative 50. And then over at where x is negative 1, we'll have a maximum of 58. So we'll say our 58's up here. And we have our maximum there. All right. Next, let's find any inflection points. Inflection points are found by doing our second derivative. So f double prime will derive again with our single prime, or our first derivative there. So we get 6x to the first now minus 12. And our inflection points occur where that is equal to 0. And so we see that x is going to be 2. And so our inflection point occurs at f of 2. And we have to go through all this rigmarole here. So 2 cubed minus 6 times 2 squared minus 15 times 2 plus 50. So 2 cubed is 8. 2 times 2 is 4 times 6. It's an 8. Anyway, that's a minus 24, minus 30, plus 50. 8 minus 24 gets me a negative 16. Minus 30 more is a negative 46. Plus 50 equals 4. So at 2, we have a inflection point roughly there at 4. So 2 comma 4. An inflection point, if you remember, is where we change concavities. So it goes from being concave up to down or vice versa. Let's also find the limits at infinity. So the limit of our function as we approach infinity, well, if we go through our thing where we divide everything by x cubed, so we'll have 1 minus 6 over x minus 15 over x squared plus 50 over x cubed. And we have to remember that we did that on what is essentially our numerator, so we have to do that on our denominator too. Our denominator was 1, now we have 1 divided by x cubed. So what we have here is on top we basically have a 1 minus 0 plus 0 all over, and I know it's sort of looks like it's going to be 0, but again it's very, very close to 0. So we have a positive number over something that's very, very much a positive number, and so we're going to end up getting a positive infinity out of this. Our limit as we approach negative infinity, if we can intuit this instead, we're going to have a really big negative number from the cube. We're going to have a really big negative number from the squared term, a really big positive number from the negative 15 term, and then plus 50. But those two huge negatives at the beginning really outdo the last two terms, so this will be approaching negative infinity. And then finally, for part D, we're being asked to graph the function. And so what we can kind of see is here on the left, we're headed toward negative infinity. On the right, we're headed toward positive infinity. And in the middle, I realize now that this is supposed to be 2 comma 4, so I graphed that incorrectly, but there's 2 comma 4. And so we change from concave down at 2 comma 4, so we're concave down up until that point, and then now we switch to where we're concave up. So we're concave up everywhere after where x is 2, and concave down everywhere before where x is 2. And so that's using our limits and our derivatives in order to graph this function. So for now, we are done.